The Bohr atomic model is a model of the atom proposed by Danish physicist Niels Bohr in 1913. This model is a modification of the earlier atomic model proposed by Ernest Rutherford, which stated that the atom had a positively charged nucleus at its center, surrounded by negatively charged electrons that moved in random orbits. Bohr's model proposed that electrons moved in circular orbits around the nucleus in fixed energy levels, rather than random orbits. These energy levels were defined by the amount of energy that an electron possessed and were referred to as shells. Electrons in lower shells had less energy than those in higher shells. Bohr's model also proposed that electrons could only exist in certain energy levels, and that they could move between these levels by absorbing or emitting energy in the form of photons. When an electron moves from a higher energy level to a lower energy level, it emits a photon of energy. When an electron absorbs a photon of energy, it moves to a higher energy level. Bohr's model provided an explanation for the spectral lines observed in the emission and absorption spectra of atoms. It also provided a foundation for the development of quantum mechanics, which is the current model used to describe the behavior of atoms and subatomic particles. Despite its limitations, the Bohr model played a crucial role in the development of modern atomic theory and had a significant impact on the fields of physics, chemistry, and engineering. Postulates of Bohr atomic model. The Bohr atomic model has the following postulates. 1. Electrons orbit the nucleus in circular paths, which Bohr referred to as shells or energy levels. The energy of an electron in a particular shell is quantized, meaning that it can only exist in discrete energy levels. 2. Electrons in a lower shell have less energy than those in higher shells. Electrons can move from a lower energy shell to a higher energy shell by absorbing energy, and they can move from a higher energy shell to a lower energy shell by emitting energy. 3. The energy of an electron is proportional to its distance from the nucleus. Electrons in higher energy shells are farther from the nucleus and have more energy than those in lower energy shells. 4. Electrons in a particular shell have a fixed angular momentum, which means that they must move in circular orbits with a specific radius and speed. 5. Electrons can exist only in certain allowed orbits, which are determined by the balance between the attractive force of the positively charged nucleus and the centrifugal force of the electron's motion. 6. Electrons do not emit energy as long as they remain in their allowed orbits. This is known as the principle of stable orbits. 7. When an electron absorbs energy, it moves to a higher energy level and becomes unstable. To return to a more stable state, the electron emits energy in the form of a photon, which has a frequency directly proportional to the energy difference between the two levels. These postulates help to explain the structure of the atom and the behavior of electrons within it, and form the basis for further developments in quantum mechanics. Limitations of Bohr model. While Bohr's model was a significant improvement over previous models of the atom, it also had several limitations. 1. The model only worked for hydrogen and hydrogen-like ions. Bohr's model was only able to accurately predict the behavior of atoms with a single electron, such as hydrogen. For more complex atoms with multiple electrons, the model's predictions did not match experimental observations. 2. It could not explain fine details of spectral lines. While Bohr's model was able to explain why spectral lines were observed in the atomic spectrum, it could not explain the finer details of the lines, such as their splitting into multiple lines in the presence of a magnetic field. 3. It did not account for electron spin. Bohr's model did not take into account the spin of electrons, which is an important property that affects the behavior of atoms and their interactions with magnetic fields. 4. It violated Heisenberg's uncertainty principle. Bohr's model implied that electrons move in definite orbits, which would mean that their position and momentum could be precisely known at all times. This contradicts the uncertainty principle, which states that the more precisely one property of a particle is known, the less precisely the other property can be known. 5. It relied on classical physics. Bohr's model was based on classical physics, which could not fully explain the behavior of subatomic particles. It was later replaced by the more accurate and comprehensive theory of quantum mechanics. Despite its limitations, Bohr's model was a significant milestone in the development of modern atomic theory and helped to establish the idea that the behavior of atoms and their constituent particles is quantized and subject to fundamental physical laws. Thank you for watching the video. Please subscribe the channel and press the bell button icon for the latest updates. Keep visiting the channel and share with friends and family.